Hello, everyone. Welcome back. Today, I'm going to talk about matrices and explain what they are, where they come from, and why they're useful. So our goals then will be able to understand what matrices are, the basic concepts, be able to perform what are called matrix row operations, be able to write a system of linear equations in augmented matrix form, explain what that is, and also be able to solve a system of linear equations using elementary row operations. So let's get started. First, let's remember what a linear equation is. A linear equation is an equation where all your variables, it can be several variables, but all your variables all to the first power. So a general linear equation looks like this. It's kind of mathematical, but all it means, x, instead of calling x, y, and z, so we don't run out of letters, we just call them x1, x2, and x plus means keeps going till xn, wherever that is. So if we have 20 variables, you have x1 through x20. If you have 10 variables, you'd have x1, x2 through x10. The a's in front are just the coefficients, the numbers in front of the x's, and they're also kind of numbered with the x's just to identify them. And then finally, on this end, on the right side, we have some constant we'll call b. Now, let's talk about systems of linear equations. And you're probably most familiar, if you've seen a previous video, with the systems of about solving systems of linear systems with two equations with two variables. It looks like this. So instead of using x and y, I'm using x1 and x2. This is an example of that, where you have two equations, also have two variables. But you can have many more equations and many more variables than that. So in general, you could have a system that looks like this. So imagine this first equation like we saw here, but several of them. Okay, so here we have m equations, so 1, 2 through m. That's why the m is the subscript right there, and n variables. Okay, we have a system of equations like that. And like I said, a system of m equations and n variables. Okay, each one of the variables and each equation has possibly different coefficient, different number in front of it. And then each equation also has possibly different numbered on the right-hand side. Okay, just kind of mathematically way in general writing all those, although it not as meaningful until you see an actual example. But that's what we have. So if you've seen a previous video on solving systems of two equations with two variables, or we've seen this before, the methods we talked about there, like the substitution method and elimination method, they can work, but they don't really work as well when you have a lot of equations and a lot of variables. So we're going to introduce what are called matrices to actually help us rewrite a system of equations like this in a better way, a more compact way, but then we actually can solve them. Okay, now, if we take a general system like this and just have two equations with two variables, in general, it'll look like this. Okay, so and let's do over here on the right, let's actually write out an actual example. The linear system of two equations and two variables. I'll just abbreviate each one of those. Okay, and so let's do a basic example. One we'll actually work with in the future. It looks something like this. So 3x1 plus 2x2 is equal to 0. And then 2x1 minus x2 is equal to 7. Okay, so this is a system like this. Okay, so we're just, in general, look like this, where you have two variables, x1 and x2, and two equations. Then actually in front of each one of your variables, in each equation, you have a possibly different coefficient, different number. And then on the right-hand side, you have a different number on the end. So for our first equation, like our constant a11 is 3. Our constant a12, also here, as we'll see, first one means essentially the row, and the second number in the subscript means the column. Our constant a12 is 2, a21 is 2, and our a22 is -1. And then our b1 is 0, and our b2 is 7. Okay. Now, as we said, for solving two systems and two equations with two variables, the methods like the elimination method, addition method work pretty well, or the substitution method, but they don't work as well when we have a lot more systems. So what we want to do then is develop something called a matrix. So basically, a matrix is a way of rewriting all these constants, okay, the A's and the B's, in a more compact way. Okay, let's talk about matrices then. So a matrix is basically a block of numbers that looks like this. Okay, so in general, we talk about an m by n matrix, where you have m rows. So row 1, row 2, and row M. And then n columns, column 1, column 2, and column n. Okay, and that's what a matrix is. Let's come over here and look at an example. In fact, we'll just make an example out of this for a matrix from this. An example, and this, of course, is also an example of an equation here. Let's make this, let's call this matrix A. A lot of times you name the matrices. So here, I'm just going to make a matrix out of this kind of the left-hand side of these equations. So here we're going to have 3, 2, 2, and -1. Okay. Now, if you notice, this matrix has 2 rows, 1, 2, and also 2 columns, 1, 2. So this is called a 2 by 2 matrix. Okay, so this is the number of rows in the number of columns, a 2 by 2. Okay, now we can name these coefficients. So and also named by their row and column. So let's say coefficient 1, 1 is actually 3. So the coefficient, the number that goes in row 1, column 1 is 3. A 1, 2 goes in row 1, column 2 is 2. A 2, 1 goes in row 2, column 1, row 2, column 1. That's the number 2. And finally, for this one, A2, 2 is in row 2, column 2. So row 2, column 2, that's -1. Okay, so that's how to think of. These are called the elements of a matrix. You can identify them by, so the small a means they belong to matrix A. They identify them by their position. Their position is given by this subscript. Okay, so once in the first number is the row, second number is the column. Okay, let's do another quick example. Let's call this one B. And let's make a different kind of matrix this time. So let me say I have 1, 4, -2, 0, 3, and 7. Okay. Now, if you look at this one, this then compare it. What size is our matrix here? Well, we have 2 rows, so it's a 2 by, we have 3 columns, 1, 2, 3. So this is a 2 by 3 matrix. And then I want to know, for example, what is it's not A, as we'll call this small b, since it's matrix B. So B of, say, 2, 1. So what is B2, 1? Well, that's the entry in row 2, column 1. So row 2, column 1, that's 0. Okay, that's the element in B1. Okay, so how about we also do a couple more? So how about B1, 2, reverse that. Okay, so in row 1, column 2, that's 4. And then finally, if we do B2, 3, and that's going to be in row 2, column 3, that's 7. Okay, so that's how you identify. So all matrices are named. They're basically blocks of numbers. Their size is given by the number of rows, by the number of columns, and then the elements are given, position of the elements are given by these subscripts where this is the row, this is the column. Okay. Now, we can actually take an equation like this and convert this into what's called an augmented matrix. And what that means, let's actually come down our second page. We want to convert our system. Let me just rewrite it again. So 3x1 plus 2x2 is 0. And then 2x1 minus x2 is equal to 7. Convert this to, let's call it an augmented matrix. Okay, and it's talks about here about how to do that. So if we have some system of equations, we're going to make a matrix out of the A's. Okay, then we're going to also attach that kind of matrix out of our B's. We'll see what that looks like. Okay, so our augmented matrix for this system is going to look like this. So we're going to have a dividing line. So what we're going to do is we're going to write on this side of the dividing line, what are called the coefficients, essentially what's called a coefficient matrix, or matrices of the numbers on the left-hand side of our equations. And then on this side of the dividing line, we're going to write the right-hand side of our equations. Okay, so basically for each, we'll kind of match the rows and columns. So for our first row, we're going to have 3, then positive 2, then on this side of the dividing line, 0. Okay, then down here we have 2, -1, and 7. Okay, so we see we just took this system of equations and turned it into what's called an augmented matrix. Now, why is that useful? Well, basically, as we'll see, especially now and in the future, a lot of times it's easier to work with systems of equations this form than it is with this. We don't have to worry about the equal signs and the variables numbers. It's a lot of times just easier to work with, especially if I do it by hand. Okay, this is called the augmented matrix of the system of equations. Now, we can also, once you have an augmented matrix like this, and what we can do, you can read some of this on your own if you like, is we can actually solve equations this way. We do what's called row operations. Oops. It's called elementary row operations. Okay, so let's talk about those. So first off, let's look back at our system right here, our system of equations. Okay, so we think about if you've done the elimination or addition method before, this would be familiar, especially these second two. So first one of our what are called equation operations is we can actually swap two equations for each other. So the order of these doesn't matter. I can make this is the first top equation right now, but I can make this the bottom equation, make this a top equation. That doesn't change anything. Okay, so I can always switch equations. I can always do that. Now, if you've known the elimination or addition method, you know you can always multiply any non-zero number by each equation. Okay, then you can also add a constant of one equation to another. So in the addition method, we add one equation to another. That's basically what this second one is. Okay, so we can add some multiple of one equation to another equation. Okay, and I can do that to any equation as long as I add the same, as long as I'm adding the same thing. Now, I can also do that for rows. So rows operations work basically the same way. I can swap two rows. Okay, I can make this is now the top row. I can make it the bottom row if I want. That doesn't matter. I can also multiply a number, a scalar number, okay, any constant. It's not 0 by either row. And then I can also add multiples of one row to another. That's what I want to practice with now, just to be more familiar with this. So first off, let's take a look. Let's use our matrix. And let's call this matrix, let's name it C. Okay, we called the others A and B. Let's call this one C. So our first row operations, so let's do row operations on matrix C. So what I'm going to do is, first off, thing I'm going to do is I'm going to do row 1. I'm going to switch with row 2. Okay, so what this means, I'm just going to switch rows. And so if I do that operation, all that means is I'm just going to put the top row is now going to be, top row will now be the bottom row. Okay, so now my top row is now going to be 2, -1, and 7. My bottom row is now going to be 3, 2, and 0. Okay, doing that doesn't change anything. Okay, now that's kind of our first rows. We can do that anytime we want. And sometimes, as we'll see, sometimes it's very useful. Sometimes it helps to do that. Now, we call it number 1. Number 2, how about we do this? How about we do 2 row 1? And the way we're going to write this is to row 1. What this means, oops. So 2 row 1 basically becomes row 1. What that means, I'm going to apply row 1 by 2. Okay, and that's going to become my new row 1. That's going to replace my row 1. So first off, in this, I'm not changing anything. I'm not doing anything to my second row. My second row is going to stay just as it is. So this is going to be 3, 2, and 0 for now. But my row 1, I'm going to change. So multiply everything by 2. I'm going to replace row 1 with that. Okay, so 2 times 2 is 4. 2 times -1 is -2. And of course, 2 times 7 is 14. Okay. And also, since I like to label these, this is my row 1 and row 2. So now this is my new row 1 and row 2. Okay. And as we'll see, as we learn when solving equations using this, that doesn't change anything. So whatever solution I had for this system of equations is the same solution I have to this augmented matrix. And as long as I do these raw operations correctly, I will always have the same solution. Nothing will change. Okay. So number 3, let's do this. How about we do -3 row 2 goes to row 2. Okay. Now I'm going to go back to my original row 1. And so I'm going to go back to my original row 1, though it doesn't have to be. So original row 1 was 2, -1, 7. Now, multiply each element of this row by -3. So -3 times 3 is -9. -3 times 2 is -6. And then -3 times 0 is 0. Okay. So now this is now my new row 1 and my new row 2. So I can multiply. That's my second rule of row operations. I can multiply each row by any non-zero number. The reason we can't use 0 is you multiply everything by 0. Then what will happen is that basically it's not so much that's mathematically wrong, it just doesn't do you any good. It makes everything 0. That doesn't tell you anything useful. Okay. Now number 4, let's do something a little more complicated, a little more involved. 2 steps in one. Okay. So this time let's once again start with my original row. Let's do 2 row 1 plus row 2, and that's going to become my new row 2. Okay. This time I'm doing 2 steps in one. So let's go back to my original matrix. So let's just rewrite my original matrix again. So we have 2, -1, and 7. Okay. And then it was 3, 2, and 0. All right. So first, we're going to do this in 2 steps because this can be kind of difficult to try to do this in 1 step. So first, let's do 2 row 1. Okay, so what that's going to look like, I think we've already done this. So multiply each, also label this as row 1 and row 2. So multiply every element, each one of our elements in row 1 by 2. So that's going to be 4, -2, and 14. So now this is now 2 row 1. My row 2 is still the same. Now then my next step, I'll say now what we want to do is we're going to add 2 row 1 to row 2. Oops, to row 2. And that's going to become my new row 2. Okay. What we have now is going to be, so now I'm keeping the same, now my new row 2, which is 4, -2, and 14. Okay. Now my new row 2, what I'm going to do is simply add these. Okay, this is much like the elimination method. So I'm going to add, so this is now 2 row 2. I'm going to add this to row 2 and replace, oops, right, this is a directional sign. I'm going to replace this row with that. Okay. So this is now 2 row 2. So 4 plus 3 is 7. -2 and 2 is actually 0. Okay. Then 14 and 0 is 14. Okay. And now this will become my new row 1 and my new row 2. And then I'll do some other operation from this point. Okay. All right. Let's do one more of those. And let's start from this. So 4, let's do minus, how would we do minus, do -4 row 2, then add that to row 1. That will become my new row 1. I'll say from here. So now I can return to the original one. We're going to do it from this matrix we have. Okay, so at the same time, let's do this in 2 steps. So first, we're going to do -4, row 2. See what that looks like. So first off, for now, my row 1 is the same. Now multiply my row 2 by -4. So -4 times 7 is -28. -4 times 0 is 0. And then -4 times 14 is, what's that going to be? Negative 72, I believe. Wait, no, is that right? I have to think for a second. No, -56. I'm sorry. -4 times 14 is -56. Okay. Now this is now -4, row 2. And now let's do that second step. I say now what we're going to do from here is going to be -4, row 1, which is right here. We're going to add that to row 1, and that's going to become my new row 1. Okay. So add these together. So my new row 1 is going to be -24 and 4, or -28 and 4 is -24. 0 and -2 is -2. And then -56 and 14 is -42. Okay. And this becomes my new row 1. And now my row 2 is now this. Okay. -28, 0, and -56. And then potentially I would do some other operation on this new matrix, which is still mathematically still, although it has different numbers, is still the same in the sense that everything in terms of a system of equations, I haven't changed anything. Okay. So that's the idea of row operations. So what we're going to do now is let's see how we can actually solve a system of equations through row operations. I actually want to solve this one. So what we do is we're going to solve this system. So I'll write it down again. 3x1 plus 2x2 is equal to 0. And 2x1 minus x2 is equal to 7. Okay. So we have a strategy for doing that. So first, write the system using an augmented matrix. We've already done that, but let's do that again. So what we're going to do is essentially make a matrix out of this system of equations. So we have this little dividing line. So this separates the left side from the right side of my equation. So I'll go and do the right side over here. So let's fill in my right side entry. So I have 0 and 7. Okay. And over here, then I put this row in. Okay. So 3 and 2. Okay. So this row is 3, 2, 0 here in the same way. This row is the same as well, 2 and -1. Okay. I'm going to label these row 1 and row 2. Now, as we'll see, what we want out of this, our goal, going through these operations, looks something like this: 1, 0, 0, 1, and then we have to figure out what these numbers are over here. Okay, if we can make it look like this, and I can show this as a unique solution. This is an independent system. I can make it look like this. So what's going to happen then? It's in this form. It's very easy to find then what our answers are, and we'll see that here in a moment. First, let's go through this. Okay, so what I would like to have is, if I want to make it look like this, I'd really like to have a 0, or I'd like to have a 1 right here. And so the one way to get that, okay, if you notice, if I just do 3 minus 2, that would give me a 1 right here. I also should back up and say there's not only one way to do these row operations, often several ways. And often through practice, you'll figure out what the best way to do it is. But here, we'll show one way. Okay. Now, remember, anytime I can also switch my rows, but right now it's not clear that would really help right away. And so I really like a 1 right here. So what I want to do then is, if you notice, if I did 3 minus 2, that would give me a 1. So what I'm simply going to do is do row 1 minus row 2 to become my new row 1. Okay, I'm to subtract row 2 from row 1. That's going to become my new row 1. Let's do that. Okay. Now, first off, my row 2 is going to be unchanged. It's going to be 2, -1, and 7. Actually, those look like a 7. Okay. Now let's subtract. So 3 minus 2 is 1. Good. That's what I want right there. Now, remember here, be careful. We're subtracting a negative. So 2 minus a -1 is actually going to be 3. Okay. Because remember, we're subtracting a negative. Okay. So 2 minus a -1. And then 0 minus 7 is going to be -7. Okay. Let's read that again. So 3 minus 2 is 1. 2 minus a -1 is +3. 0 minus 7 is -7. Now, this is my new row 1 and row 2. Okay. Well, also what I'd like to have is I'd like this to be 0. So think about it. If this was a -2 and I added them together, that would make that 0. So I can do that. I can use row operations. Okay. So what I want to do next then is I want to do essentially -2 row 1 plus row 2 will be my new row 2. Okay. So if this was a -2, if I added those, that would make that 0. That's what I'm going to do. Okay. Now, first, as I did before, first, let's do -2 row 1. So if you try to do too many of these in your head, a lot of times, again, it's easy to make mistakes. So let's do that first. So just multiply -2 times my row 1. So I have -2. -2 times 3 is -6. And then -2 times -7 is +14. Okay, and now my second row is the same. So 2, -1, and 7. So this is my -2 row 1. Okay, so now with that, what I have, now this is still my row 2. So now we're going to add those. Then. So now we're going to do -2 row 1 plus row 2, and that will become my new row 2. Okay, if we do that, let's take a look what happens. All right, so -2 and 2 is 0. -6, we just add them. So -6 and -1 is -7. And then 14 and 7 is 21. Okay. Now I'm actually going to go back to my previous. Remember, so I want in the first, what I want here in my first place is a 1. I already did that. So instead of using this row 1, I'm going to go back to my previous row 1, which is this 1, 3, and -7. Okay. Let's take a look, see what we did. So now we're getting closer to what we want. Okay. We have a 1 here and a 0 here. Let's look back at our goal, what it was we wanted. And we said we wanted was like this. So what I'd really like now is a 1 here and a 0 here. Okay. Oh, so this is my new row 1 and my new row 2. See what we have now. So now actually 21, you could divide that evenly by 7. So actually, if I just divide this row by -7, that will give me a 1 right here. So what I'll do now then is negative, -7, or divide it by -7 rather. So you can write this as -1/7 row 2 to row 2. So basically, I'm essentially dividing this row by -7. My row 1 is going to be still the same for now. So we have 1, 3, -7. Now here then, I'm going to have 0. So divide that by -7, that'll be 0. Divide this by -7, that will become 1. And divide this by -7 is going to be -3. Okay. All right. We're getting really close to what we want. Okay. Let's stop a minute. Okay. Our last thing we want is 0 right here. So now this is 1. It's not hard to make that happen. So imagine if this was a -3 and I added these together, that would make that 0. So what I want to do then is do row, so -3 row 2, write that better, -3 row 2 plus row 1, and that's going to become my new row 1. Okay, so let's first we'll do the first step. I'm not trying to do them all in my head at once. Okay, so no, minus first, sorry, row 3 or minus 3, row 2. So for now, my row 1 is unchanged. And now -3 times this, so it's going to be -3 times 0 is 0. -3 times 1 is -3. That's what we wanted. And the -3 times -3 is +9. Okay, now this is row 1 and this is -3, row 2. And now let's add those, replace row 1 with that. So now -3, row 2 plus row 1 goes to row 1. And that will basically give me what I want. And now if I add those, 0 and 1 is 1. -3 and 3 is 0. And 7 and 9 . Oops, sorry, this should actually be there we go. Oh, something look wrong. This should be a negative right here. Sorry about that. And then 9 and -7 is going to be +2. And then now I'm actually going to go back to this previous row 2 right here. I was 0, 1, and -3. Okay. Now, why is this what we wanted? Well, from here, now I'm going to just rewrite this. Okay. So look back at our strategy. First, write the system using augmented matrix. We did that. Use these elementary operations to basically get to a version. We can easily find the constants, the constant values of the variables. And we'll see in a minute that's why this is useful. And now write the solution of the system. Okay. Now I'm going to rewrite as a system of equations. Okay. So let's go back just a moment and take a look where this augmented matrix came from in the first place. Okay. So if we remember, going back too far. Yeah, here we go. Okay. Remember, so this, for our pattern, these numbers over here were on our right-hand side, right-hand side. And this was the coefficient in front of x1 and x2 in the first equation. This is the coefficient in front of x1. This is the coefficient in front of x2 in the first equation. And this was the coefficient in front of x1, and then the coefficient in front of x2 in the second equation. Okay, so I'm going to do the same thing here, basically going backwards with this. And what I'm going to have then is this going to be 1, or going to be 1x1 plus 0x2, since that's a 0 in front of x2 would be equal to 2, and 0x1 plus 1x2 is equal to -3. And of course, you notice that's 0, that goes away, that goes away. So what I have then is x1 is equal to 2, and x2 is equal to -3, and that's my solution. Okay, so I use those elementary row operations then to get to a solution. Okay, now you may be thinking, and you're also correct for this, that basically the substitution method, elimination method would have been much faster for this, and that's true. But as we'll see, this method is much quicker than other ways of doing it if you have many equations with many unknowns. Even like a system of 3 equations and 3 unknowns, trying to use the elimination method, the substitution method would be really difficult. Okay, now let's take a quick look at another system, and actually give me just a moment. I need to change something. Okay, and actually I need to give me also a moment. I need to make sure I have enough usually paper to work with. So let me go where I was. Let me actually add a few more. Hopefully I have more than enough. So we'll look at a couple more examples. Yeah, that should be more than enough. I just want to make sure that I don't cause any problems later. Okay, let's look at a second example. So number 2. So number 2, let's say I have this system. x1 plus 2x2 is equal to 1, and 2x1 plus 4x2 is equal to 4. Okay. Now, once again, I want to solve this system. But once again, write is an augmented matrix. So if we do that, right, just as we did, so we're going to have a 3 by 2 matrix, remember, so, or a 2 by 3 matrix, 2 rows and 3 columns. Over here, we have in the first row, we have this equation, my right-hand side is going to be on the side of this dividing line. So this coefficient is going to be 1, so 1. This coefficient is positive 2, and this coefficient is 1. The number is 1. Down here, I'm going to have 2, 4, and 4. Okay. Now, next one's one more practice with this and also show you what can happen if you recall, when you have systems of 2 equations and 2 unknowns, you can have either what's called an independent system, where you have one solution, just like we had here. You also have what's called an inconsistent system, where there's no solution, and also a dependent system, where both equations are actually equations of the same line. So every point on the line is a solution. So I want to make sure we look at examples like that. Okay. Now this is going to be our row 1 and row 2. Remember, what I want to get out of this, if I can, is going to be this 1, 0, 0, 1, and then some numbers over here on the right side, which you have to find. Okay. Now, in the same way, so let's see if I can kind of match what I did. Now, if you notice right here, this is already 1. That's good. I want this to be a 0. So if you imagine, if this was a -2, if I added these together, that would make that 0. Okay, so we know how to do that. So what I'm going to do is do -2 R1 plus R2, and then that will become my new row 2. Okay, so once again, as we did, so first, let's go to the next page. I'll say first, let's do -2 R1. Okay, so row 1 is 1, 2, 1. So we're going -2, and so that's going to be, okay, 1, 2, 1. So that's going to be -2, -4, -2. Okay, double check that, right? And then my row 2 stays the same. So it's 2, 4, and 4. So this is -2 R1. This is row 2. Now, once again, I want to add these together, replace that with the result, make that my new row 2. Once again, so do this step. So I'll say now -2 row 1 plus row 2 then goes to row 2. Okay, so let's add these, combine these. Now I'm going to go back to my previous row 1, which is 1, 2, 1. Since that's the one I want right here, 1, 2, 1. Let's go ahead and write that. Now let's add these. -2 and 2 is in fact 0. That's what we want. But also over here, if you see what happens, this becomes 0 as well. -4 and 4 is also 0. And then -2, and combine these, -2 and 4 is 2. Okay. This is my new row 1. This is my new row 2. So what does this mean? Well, what this tells me is that basically there's no way actually in this case, I can't get to what I want. There's no way I can get to 1, 0, 0, 1. Okay. From here, I'll say I can't get to what I want, which is 1, 0, 0, 1, and then, something unknown here and here. I can't do it anymore. There's no way I can make this. There's nothing I can't multiply this or add anything to this to give me a 1. Okay, without fundamentally changing it. Okay, now what I'm going to do then is rewrite as a system. Okay, just as I did before. I'm going to take this and rewrite it as a system. All right, so I have 2 equations. And so this is going to be on my right-hand side of my first equation. This is going to be the coefficient of x1. So 1x1 plus 2x2. Okay. But here I'm going to have 0x1 plus 0x2 is equal to 2. Now, if we kind of simplify that, what we have is just x1 plus 2x2 is equal to 1, which is basically what we started with. But now, if you notice over here, what we have is just, of course, these are all 0. So now we have 0 is equal to 2. Okay. Now, this, of course, is a false statement. It's not true. Obviously, 0 is not equal to 2. If you notice, all my variables here are gone on this equation. So there's no value of x or y I can plug in that will make this true. Okay. My x and y's are up here. I can't plug anything in for x and y to make this a true statement. So what this means, this system has no solution. So if you get a false statement like that, you can recognize that here. So if you get here a row of zeros in front of the in front of the dividing line, then a different number besides 0 over here, that means there's no solution to the system. Okay, there's basically no way to. Basically, these are parallel lines. There's no way, no values of x1 and x2 I can plug in. They'll make that, we'll solve both at the same time. Okay, that's how you recognize it then. On this side of your dividing line, if you have all zeros, this side of your dividing line, you have something that's not 0. That's a false statement, and there's no solution. Okay, let's do one more. So you can see the other situation, so you may expect what's going to happen here. So let me actually go down to the next page. Okay, so now I'm actually going to do basically a similar equation. So x1 plus 2x2 is equal to 1, and 2x1 plus 4x2 is equal to 2. So this equation is the same as the first one. This is very similar to the other one. Okay, and what we're going to see is, as you expect, that this is going to be a case where we have both are equations of the same line. Okay, but let's approach it the same way. So let's find our augmented matrix. If we do that, we're going to have a 2 by 3 matrix. Okay, so my first row, my first equation makes my first row, and then this dividing line separates the left-hand side from the right-hand side. This is going to be 1, 2, 1, and then the same thing down here, 2, 4, 2. This is my row 1 and my row 2. And then the same way, I want to make this 0. So actually, I'm going to do the same operation I did before. So to make that 0, I want to do -2, row 1, plus row 2. I'm going to make that my new row 2. So once again, first, we're going to do -2, row 1. Just multiply the first row by -2. That's going to have -2, -4, and -2. This is -2, row 1. My second row is the same for now, 2, 4, and 2. Now I add them together and make that my new row 2. So I do the complete step. So -2, row 1, plus row 2 becomes my new row 2. So I add these together. And as before, I have a 0 here, which was actually I'm going to return to my previous row 1. Because I have the 1 here, which I want. This has become 1, 2, 1. Now, if I add these together, I do get 0 here. And like before, I also get 0 here. But finally, I get a 0 here. -2 and 2 is 0. Okay. Now, this is my row 1 and row 2. Now, once again, I can't get what I want from this either. Okay. Also, cannot get 0, 1, 0, 0, 1, and then some constants on this side. Okay. Now, once again, I'm going to write this as a system, and we'll see what happens. Let's do that. If I write this as a system of equations, so this is going to be, I have 2 equations. So on this side of my dividing line, the right side, I have 1. This is the coefficient for x1. So 1x1 plus 2x2 is equal to 1. That's my original first equation. But now I have 0x1 plus 0x2 is equal to 0. If you notice what I have now, this is going to be, so x1 plus x, there's x1 plus 2x2 is 1. Then I have 0, or basically it's going to be all zeros. What I'm going to have is just 0 equals 0. Okay. Similarly, the one before we had, remember, 0 equals 2, which was false. Now I have 0 equals 0. This is true. In a similar way, this is always true. There are no values of x1, x2 I can plug in that will change that. This is always going to be true. 0 will always equal 0. Okay. So what this means, this is a dependent system. Okay. So both are equations of the same line. Okay. Now, what I'm going to do, so both are equations of the same line. What I'm going to do then is I'm actually going to solve this first equation for x2. Or for x1, rather. If I do that, I subtract 2x2 from both sides. That gives me x1 is equal to 1 minus 2x2. Okay. And now what I'm going to have then is I'm going to make, I'll say then, make x2 is equal to some number I'm going to call t. Okay. Where t is basically any number. And so then that means that x1 is equal to 1 minus 2t. So why did I do that? Well, basically, I can make t any number I want. And so as long as I pick t, if I make this my x1, then that is a solution to this system. So actually we have an infinite number of solutions, okay? Because t can be anything you want, we have an infinite number of solutions. So it's an infinite, repeat that, number of solutions. I'll say of the form, or that look like x2 is equal to t, and then x1 is equal to 1 minus 2t. Okay, you pick any t you want. As long as you do that, and as long as you make x1, pick anything, any value you want for x2, as long as you plug that in for x into this for x1, that'll be a solution to that system. They're all points on the same line. Okay, so let's take a look and see what we've learned today. So what we learned is that basically the idea is we can extend the idea of a system of linear equations to as many equations as variables as we want. And then basically we can write what's called a matrix, which is a block of numbers. We learned a bit about matrices, kind of their dimensions, how he's talked about the dimensions, what the entries are. They're called elements of individual numbers. Then we learned how to make an augmented matrix. Okay, we'll take an equation and turn it into an augmented matrix, where we have look at our examples here. We have basically all the numbers on the right-hand side. Yeah, so an equation like this. On the right-hand side, we have our this side of this dividing line, we have our right-hand side numbers, make this column. And then the rest of it, this block here on the left-hand side of our dividing line, we have the coefficients of our variables. And then we can do what are called elementary row operations on those. And once again, the elementary row operations, we can switch rows anytime we want. We multiply any row by any non-zero number. Then we can add multiples of one row to another. And we showed how we can use those elementary row operations then to solve an equation by writing it in a form it's easy to find the solution. Okay, so if we can write it in this form here, where on this side of the dividing line, the right side, left side, we have 1, 0, 0, 1. If we do that, then that's an independent system as one solution, and then we can actually pick out what our solution is. And then finally, if we get a row of, or we have zeros on the right side and left side of our dividing line, and something non-zero on the right side, that means there's no solution. And then if we do these row operations, if you get something like this, where we have zeros, an entire row of zeros, then that means we have essentially both equations for systems, two equations and two unknowns. We have, they're both equations of the same line. And basically, as long as you pick a number on that line, you have an infinite number of solutions. In future videos, we'll see how we can extend these ideas, these concepts, to systems of more equations with more unknowns. Thank you. Have a good day.